The Earth's surface has been constantly changing over millions of years. A number of plates floating on a sea of magma form the Earth's crust. This is known as plate tectonics, and we in the Caribbean are an everyday witness to the effects of these movements.
In the Caribbean now, what we've got is that we are exactly at the place where we've got the contact between two tectonic plates. One plate is the North American plate, the other one is what we call the Caribbean plate. Both of them are trying to go one towards the other, so we've got a problem because they collide. What happens is that the North American plate, it's much older than the Caribbean plate, so it's much denser, much more heavy. So what happens is that it actually goes underneath the Caribbean plate.
And as the cold material gets into the hot material, it generates earthquakes similar to like hot oil and water. So the earthquake cracks the layer of the Caribbean plate, forces magma out, and slowly but surely you have these islands building up until they actually emerge from the sea.
At the place where one plate is going underneath the other, that's what we call the subduction zone. But on both sides, on the north side and the south side, especially in the Caribbean, what happens is that the plates are not moving one towards the other, but sliding one with the other. So this is what we call a transform boundary or transform fault, and you don't have the same kind of magma production. You don't create all these big amount of molten rocks, but what happens is that you've got big fractures in the earth crust, and with the big fractures you've got lots of pressure going around, and you actually create mountains, and you create basins as well, like you can have some lakes or you can have some mountains.
There are 5 spectacular yet diverse features found in the Caribbean that are related to this tectonic activity. Each of these unique features contributes to a definitive Caribbean geography.
Dominica is an island full of volcanoes, and what happens when you've got volcanoes is that you've got heat, a source of heat underground, which comes from the magma, the molten rocks. And when there is rainwater falling down, infiltrating into the ground, it actually meets the heat and some gases from the magma. So they will actually tend to rise up to the surface. And then you will have what we call fumaroles, or just gases emanation from the ground. The problem is that on land you might not be able to see them because this is very diffuse, but underwater it will produce bubbles. So what you observe in Champion Beach in Dominica is just an expression, just these bubbles coming from the ground. And this is called a hydrothermal system. So this is very typical from old volcanic islands in the Caribbean. go to the islands, you will see this yellow deposit, you will have a sulfur smell. All this is just the expression of what we call a hydrothermal system. So this is when rainwater infiltrates the ground, meets some heat, is heated up by the magma, and also is mixed with some gases coming from the magma. So what happens if these gases are really hot and they reach the surface like this? They will actually tend to deposit a lot of minerals. Some yellow minerals will be rich in sulfur. You will have loads of different chemical elements depositing on the ground. So if you go to Sulphur Spring, for instance, in St. Lucia, you will observe a lot of gases coming out and all these deposits around, which are mainly sulfur minerals.
Each color, as you could see, represents different chemical or mineral deposits. For example, sulfur is pale yellow, the copper, green like malachite, white is calcium sulfate, black is carbon, orange alkaline lead. You do get iron oxide, manganese, and quartz crystals.
The gases at Sulphur Spring or Waterwaven in Dominica are made of water. It's more than 90% of water. But then you've got some other elements like sulfur. This is the rotten egg smell you can have, and also fluorine and chlorine. So a whole range of different chemical elements. So this is again something very typical from still active volcanic systems when rainwater is infiltrating the ground and coming back up to the surface.
The only time you find the level of activities tend to be more vigorous is normally when it rains heavily. You can imagine very misty, very foggy, but a bit smellier too.
What the pitons are in St. Lucia, they are all centers of activity, basically all volcanoes. They were active probably millions of years ago. And what happened is that some magma just went close to the surface. So basically that's what we call the magma intrusion. And then it stopped and was frozen. What happened then is that with the work of the erosion, basically the work of water, it actually eroded all the material around it. So you don't actually see the volcano anymore. What you see is the plumbing system, if you wish, the frozen plumbing system. And this is what we call a neck or a magmatic intrusion. And it took hundreds of thousands of years to form. Trinidad is just basically at the boundary, at the transform boundary of two plates. So where the two plates are not colliding one to the other, but basically sliding one from the other. The pitch lake in Trinidad is made of asphalt, and all the asphalt means that we had loads of organic matter, so basically dead organic matter, buried through the years. So that was millions of years ago. And then when we had this transform boundary, so in other words, we've got loads of pressure in the earth crust, some of the organic matter which transform into oil and into pitch.
What we had is a big anticline, which is, to put it simply, typically we find these anticlines forming hills. And with these folds, we tend to have what we call faults, which are breaks in the rock. Oils migrated up these faults towards the surface and basically formed this big pool of pitch.
Trinidad and at the Pierce Lake, we've got fractures which are basically pathways for this pitch or oil. Usually when you've got, around the world, when the beaches are quite white, it's mainly because the sand is made out of coral or sometimes made out of real sand, basically silica. What happens in the volcanic islands is that the rocks around, the sand comes from the erosion of the rocks on the island. So the color of the sand will depend on the nature of the rock in the island. In all the volcanic islands in the Caribbean, we've got loads of, well, we had, for the past eruptions, we had loads of magma, what we call basaltic magma, which is something, a rock, a volcanic rock, which is darker in color. So what happens is that the sand produced by the erosion of this rock will tend to be darker. And actually you can give it a try. If you take a handful of sand like this and you put it close to a magnet, you should see lots of pieces of the sand coming onto the magnet because you've got a lot of what we call ferromagnesian minerals in there.
Dominica is the youngest island in all of the Eastern Caribbean states, and actually there's like 44 sandy beaches on the island, and 42 of them are black sand beaches because of the island's volcanic origin, and only 2 white sand beaches on the northeast section of the island.
There are countless examples of tectonic activity to be found in the Caribbean, all evidence of the region's violent formation, continuing to boldly demonstrate its common geography.
All the islands in the Caribbean are formed more or less by the same process, which is linked to what we call the subduction zone, one plate going underneath the other, producing some magma, the magma coming up to the surface and producing volcanoes. If you look carefully on the map, you've got 2 arcs, what we call arcs. The western side is the active volcanic one, where all the islands have potentially active or active volcanoes like Montserrat, French Antilles, Dominica, St. Lucia, and so on. And the eastern arc on the eastern side is actually remnants of the old volcanic arc. But because the actual subduction zone changed the geometry, this part is not active anymore, and then all the island went underwater, and we actually built some limestone and coral on top of it. So this is, for instance, Antigua and Barbados. So all the activity actually moved on the western side of the Caribbean as we know it now. So all the islands are made by the same process, which is the geologic processes. It doesn't mean that the islands are linked one with the other. It's not because we've got an eruption in Montserrat that we will have an eruption in St. Lucia. This is a very important point. But all of them actually come from the same process. That's the main idea.